Hi, welcome to Unit 6.3 Kinetics video. This is part 1 of 3. All right, in this unit, we have learned how to determine rate laws. And remember, those are the laws that, or the equations which show the relationship between rate and concentrations of reactants, or sometimes products. And we know that rate laws must be determined experimentally. And there are several ways of doing that. And we've already covered the first two ways, method of initial rates and from plots of concentrations versus time. So just to show you what those look like. So for method of initial rates, we get a chart like this, and we use that to determine the rate order of the reactants. So that would be the X and the Y. And then we can use the rate values and the concentrations with our newly found rate orders to solve for K. So we would get a rate law that looks something like this, where we've found our K, our rate constant, and our rate orders. We also learned that we can determine rate laws from plots. So remember, we're looking for a plot that gives a linear graph. And for zero order, it's concentration versus time. For first order, it's natural log of concentration versus time. And for second order, it's 1 over concentration versus time. And all three of these plots, the slope will tell you what K is. Okay, so what we're going to learn today is how to determine the rate law using elementary steps of a mechanism. So first, let's talk about what a mechanism is. So a chemical reaction, even though when you're looking at a balance equation, looks like it occurs in one step, it actually usually occurs over several steps. And again, that's not evident in the overall balanced equation. And those steps that we don't see are known as a reaction mechanism. So that sequence of steps are known as a reaction mechanism. And each step of the mechanism is known as an elementary step. So it's sort of like the basic or fundamental step. And when we say element, we mean sort of like the basic or piece of the overall reaction. During the elementary reaction, intermediates are made, and we'll talk about what they are, and then they're also consumed. But the thing to note is that intermediates are not reactants or products of a chemical reaction. So there's something that sort of is made during the mechanism and then used up. So let's talk about how do we identify intermediates. So here we have this overall reaction, A plus B going to C. And here are the steps of that reaction. Now, first of all, when you add up those steps, they should equal the overall reaction. So you'll notice that, we'll look at that later, when you add them up, you'll get 2A plus 2B goes to 2C, which sort of simplifies to A plus B goes to C. So let's see how we can identify the intermediates. So let's look at that first step. So A, they're reactants. So I'm boxing that in gray because it's a reactant, so it's not an intermediate. But then that goes on to make D, and if you look in the overall reaction, you don't see D anywhere. So that's neither a reactant nor a product. So that's our intermediate because we make it first. And then if you look at step 2, we consume it in step 2. So it gets made and then it gets used up. So it will cancel out in the mechanism. All right, see if we can find any other intermediates. B is a reactant, so that I boxed in gray, and then E is made, but that's not a reactant nor a product, so that means it's an intermediate. So E is also an intermediate because it's first produced and then consumed as a reactant. All right, let's try it again here. In step 1, X is a reactant, and we can see that in the overall reaction. And then we look at A, and A is not in the overall reaction. But A is actually not an intermediate, so I put it in a box as well, and I put it in green. So we see that that A is known as a catalyst, and I'll tell you what's the difference. So for a catalyst, it's first found as a reactant because you add the catalyst to the reaction, and then later on you make that catalyst back again as a product, and so that's the reason why the catalyst cancels out. So just like the intermediate will cancel out because it's found on both the reactant and product side, the catalyst will also cancel out. But the difference is for a catalyst, you'll see it as a reactant first and then as a product. Whereas an intermediate, like B, you see it as a product first and then in a subsequent step as a reactant. So the other intermediate here we have is Y and Z because again, you see it as a product first and then a reactant. So intermediates are made first and then consumed. Okay, so I want you to, in this first CFU, see if you can identify the intermediates. Pause the video. When you press play again, the answer will be revealed. Okay, so the intermediate in this reaction would be N2O. That's our intermediate. It is made first as a product and then consumed as a reactant in step 2. All right. So now I want you to try this again with CFU2. Which of the following are intermediates of the above reaction in this mechanism? So looking at this mechanism, which ones are intermediates, and make sure you look at the overall reaction above. Pause the video now. When you press play again, the answer will be revealed. Okay, so the intermediates here are Cl and Cl3. So that would be choice C, which has Cl and Cl3, and sort of circle them. So again, you can see that it's Cl is made first as a product, and then it's found as a reactant. And the same thing with CCl3. All right, that's it for part 1. Hope you have a quality day, and we're going on now to part 2.